This is Captain Ross with 3B's Captain School, and this video is on vessel maneuvering in our deck video series. We're going to cover vessel maneuvering, our objectives that we want to be able to meet when we finish this video. We want to be able to define common mariner terms, state environmental forces that affect maneuvering, state factors that affect maneuvering, like vessel factors, those kind of things. Describe factors that affect maneuvering in narrow channels or rivers. State factors to consider when operating in heavy weather. All right, so definitions. The bow. The bow is the front end of the boat. Moving forward, the bow is going forward. When the boat moves forward, it is going ahead. When facing the bow, the front right side is the starboard bow. The front left side is the port bow. Amidships is the central or middle area of a boat. The right center side is the starboard beam. The left center side is the port beam. The stern is the rear of the boat. Moving forward, the stern is aft. When the boat moves backwards, it's going astern. So when we back our car up, we say we're backing up. On a boat or a ship or vessel, when we're going backwards, we're moving astern, or we're going astern. Standing at the stern looking forward, the right rear section is known as the starboard quarter, and the left rear section is the port quarter. Starboard is the right side of the boat from bow to stern. Port is the left side of the boat from bow to stern. And athwartships is like right down the center of the boat. Outboard, from the center line of the boat towards either the port or the starboard side, we refer to that as going outboard. Inboard, if you're on the outboard side, like you're near the gunwale and you're moving towards the center line of the ship, that's known as going inboard or inboard. Topside is moving from a lower deck to an upper deck. A weather deck is a deck that's exposed to the elements. It's literally exposed to the weather. Windward, moving in the direction from which the wind is blowing. Leeward is the opposite of windward. Beam, the width of the vessel at its widest point. Displacement is the number of long tons of water displaced by a vessel when afloat. That's a term we use when we want to describe the actual weight of the vessel. It's displacement, and it's measured in long tons. So we have a diagram here. We can kind of go over these terms there. Here's our bow. This is going forward. If we're moving from here to the front of the boat, we're going forward. Port bow, starboard bow. Athwartships, amidships. Here's our port beam, our starboard beam. So if I'm standing here and I'm moving out, I'm going outboard. If I'm standing here and I'm moving in, I'm going inboard. Here's our port quarter, our starboard quarter. If I'm here and I'm moving towards the stern, I'm moving aft. And then here's our stern, the very back of the boat. All right, so let's talk about some environmental forces that affect the movement of a vessel. We're going to talk about wind, seas, and current. Wind acts upon any portion of the vessel above the waterline. So the amount of surface area exposed to the wind determines the sail area, and combined with wind velocity, the speed of the vessel will drift downward or leeway. So the more sail area you have in the vessel, the more effect the wind's going to have on maneuvering, and the quicker you're going to move downwind, or the more leeway you're going to have. Seas affect your boat in various ways depending on their height, direction, and spacing, like how much time is between each wave. It is critical that you know the limitations of your vessel in relation to the sea state. Some factors to consider when evaluating the sea state: a larger sea with a long period, say a 5-foot sea at 12-second period, can offer a comfortable ride, while a smaller sea with a shorter period can be brutal, let's say 3 foot at 4.5 seconds. So often when I'm looking at the weather to decide whether to go offshore, I look at the wave height in addition to the predicted weather for the rest of the day, but the wave height and the period. And the period really is the more important of the two factors, within reason. I mean, once it's over 5 foot, 6 foot, you're getting kind of bigger seas. But I have been underway in 10 plus foot seas with a really long period and still had a pretty comfortable ride. current acts on a vessel's underwater hull in the same manner as wind pushes on a vessel's superstructure. So the amount of draft the vessel has will determine the current's effect. So if you have lots of sail and not a lot of draft, the wind's going to really affect you, especially when you're doing close quarters maneuvering. If you have not much sail area, but let's say a deeper draft, and the current's going to have a more exaggerated effect. Either way, when you're operating a vessel in close quarters, when you're getting ready to come into a mooring or an anchorage, or you're going to tie off to a dock or approach a marina, you need to make sure you're well aware of the wind and the current and how they affect your vessel. All right, propulsion. The key to powered propulsion movement is the effective transfer of energy from a source of power, which is an engine, to the water through a mechanism that turns the engine's power into thrust. And for this, we use propellers. Here's a diagram of a propeller to the right here. When rotating this propeller, when rotating and move forward, the propeller draws a supply of water from every direction forward of and around the blades. So it's drawing water all in this area here. Each blade's shape and pitch develop a low pressure area on the forward face of the blade and a high pressure area on the after face of the blades, or the back. So low pressure up front here, and then a high pressure area on the back where this discharge screw current is giving you that propulsion. So this is the propeller. We have a diameter of the propeller, which we'd measure from the center here to the edge of the propeller blade. And then we have the pitch. And pitch means how far this blade would move if it rotated one full rotation. So if the blade's sitting here and I rotated it one time and it moved 28 inches forward, then it would be a 28-inch pitch blade. So then we've got two basic types of propeller blades. There's a right hand, which when it's spinning clockwise, it moves the boat forward, and a left hand, which when it's spinning counterclockwise, it moves the boat forward. So if we have a vessel with twin screws or two motors and two propellers, usually the starboard one is a right-hand propeller and the port one is a left-hand propeller, and they kind of balance each other out. All right, side force is another effect of effective propeller rotation. In addition to creating thrust along the shaft axis or forward, propellers tend to walk. So in this example right here, we have a right-hand propeller, and it's going to tend to kind of push side force out the left side, which means it's going to walk or move to the starboard when you're moving forward. And then a left-hand propeller would do the exact opposite. So cavitation is unequal blade tip speed and is caused by air bubbles around the propeller blade tips, so it won't work as well and propel you as well through the water if you have too much air around the propeller blades, because you're not getting as much thrust from that air as you would through the water. Steering is usually done via a rudder. When the vessel moves forward through the water, even without propulsion, the rudder is normally used to change the vessel's heading. As the hull moves forward and the rudder is held straight and steady, pressure on either side of the rudder is relatively equal, and the vessel will usually keep a straight track. So here's some diagrams to kind of help us with that. Pressure is equal on both sides of the rudder, so the vessel is going forward. Now we have the rudder turned, so pressure is greater on the port side of the rudder than the starboard side of the rudder, and it's going to make the stern come to the starboard, which turns the bow to port. With propeller thrust added, pressure is still equal on the rudder, and the ship goes forward. So we've got propeller added here. It's pushing water across this rudder, but it's equal on both sides, so the vessel's going forward. Rudder is amidships here. With thrust added, pressure much greater on the port side of the rudder. So now we're going to turn that rudder to the port again, and then in addition to the vessel moving through the water, we're going to have that propeller thrust, our propulsion, going over the rudder. It's going to really increase that pressure on the port side. So the stern's going to come over to the starboard side, and the bow is going to move much sharper to the port. So here I've marked the pivot points for these vessels. And the pivot point's basically the turning point for a vessel. And it's normally 1/3 of the way back from the bow when you're going ahead, and 1/4 of the way up from the stern when you're going astern propulsion. All right, so let's talk about turning real quick. Understanding vessels' turning characteristics is critical to safe operation. So if you've driven boats, which you all have, you know that a boat doesn't turn as sharply as like a car. You slide along the same direction you're originally going when you're making that turn. So up to the time the boat turns through 90 degrees, the boat has continued to advance on its original direction. And by the time the boat has turned through 90, it is well off to the side of the original track, and that distance we call the transfer. So in this diagram, here's my boat. I put the helm over to the port right here. By the time it takes me a while till I'm 90 degrees off that original course I was at, and that distance going forward along my original course, the distance I traveled along the original course, is called the advance. And then the position I was in when I started that turn until I'm over at that 90 degree, that's called the transfer. So if you look here, we've got advance and transfer. And that's the distance, extra distance we have to consider when we're trying to turn a boat that we wouldn't have to consider turning a car. All right, maneuvering in narrow channels and rivers present different challenges in open water. Here's a couple of them. So bank cushion occurs when operating in close proximity to the bank and refers to a boat being pushed away from the nearest riverbank. As the boat moves ahead in the river, the water between the bow and the near riverbank builds up high on the side of the boat, causing the bow to move away from the bank. So if you look at this diagram here, here's the channel. We're going along. It's got a steep-sided bank. This is really affects full displacement vessels. So what happens is where my cursor's at here, water pressure builds up on the bow and it pushes the bow away from the bank. So when the bow's pushed away, the stern is sucked into the bank. So we have what we call bow cushion or bank suction or stern suction, where the stern's getting sucked in. And if you look at this diagram on the bottom, this is kind of exaggerated, but if I don't correct this by turning into the bank a little bit, I'm going to get pushed away pretty hard with my bow. So this is bank cushion and bank suction. In a following current, a vessel will pick up speed but lose some control. It is important to anticipate this in maneuvering, especially in tight turns or when other vessel traffic is present. It is often necessary to begin a turn earlier and with more power due to the push from the current. Operating a vessel into a current is easier than a following current, although the operator still needs to proceed with caution in making turns and guard against turning too early. An early turn in the current may push the vessel towards the side of the channel and require corrective action. As you can see, I have two diagrams here to kind of help us draw this out. So in the first one, we have a following current, and we're going with the current through this turn. So as I'm making this turn, the current's really acting on this quarter right here and trying to push this quarter over towards the port side or left-hand bank. And I have to just kind of be careful of that when I'm turning. I don't want to make a full turn because I'm going to totally spin this boat out going with the current. When I'm driving into the current, that same effect is on my port bow. That current's really kind of stacking up there. So I have to make sure when I'm going through, I'm going to be able to turn a little bit, have a little bit more maneuverability because I have a lot more water going across my rudder. But I still have to kind of watch that I'm not getting pushed to that outside bank from my bow. So shallow water operations also require extra precaution. Vessels handle differently in shallow water. Shallow water tends to make a vessel's stern squat lower than in deep water and can produce a bigger wake. So when you're in shallow water, there's basically, if you think about it, there's not enough water pressure underneath your stern to hold it up as high as it normally would. So it'll squat farther. And when it squats farther, it makes a bigger wake. So it's just something to be conscious of when you're in shallow water, and as it relates to the draft of your vessel, you may have a little bit more draft than advertised, and you're going to create a bigger wake. So let's talk about berthing and unberthing. It can be very difficult. As the captain, you must know how your boat handles in close quarters and take into consideration the wind, current, and available sea room when you're maneuvering. So we always check throttles before we enter any kind of fairway in a marina or a tight channel going into a marina or an area that we want to further our vessel. Maneuver slowly. Slow is pro. We want to have good communications with the crew and dock hands handling lines. And then once we're moored up before we leave the vessel, we want to check all lines to make sure they're properly secured. I have a quick diagram here. If you look at lines 2 and 3, these lines keep this vessel from moving forward or back while it's moored up or berthed. And then we have lines 4 and 1, and their job is really, they are keeping it from going fore and aft, but they also hold it to the dock. So I always think of my stern line and my bow line is just holding my boat to the dock, and then my 2 spring lines in the middle, I'm using those to keep my boat from moving forward or ahead. You want to make sure the boat's secured. We want to tie these cleats off with 1 round turn and 3 figure-8s. Like I said, we want to take our time when we're mooring up. Although this guy's not going to go anywhere, he probably doesn't have to tie off too good to keep from floating away. It's definitely not how you want to have your boat moored up to the dock. All right, heavy weather. Operating in heavy weather is not necessarily an emergency. However, it does require the captain and crew to make sure they're fully prepared to operate in potentially extreme conditions. General precautions to take in heavy weather. Maintain a plot on the vessel's electronic nav equipment. Evaluate whether passengers should don life jackets. I know as soon as I ask myself the question on whether or not I should have passengers put on the life jackets, I know it's time to have them put on the life jackets. The fact that I even thought about it means that my unconscious must be telling me the conditions are such that for safety I need to have them put on their life jackets. You need to ensure all equipment and gear on board is secured for heavy weather. You want to check your bilges frequently. In head seas, you want to go slowly and be prepared for swells with very steep backs, so you don't want to launch off the back of a wave. And in following seas, you want to stay on the back of a wave by matching its speed. You don't want to overtake the waves because you might surf down the front of one and lose control. So you basically just take up station right on the back of the wave and match speed with the waves. And if you find yourself in the position this Coast Guard boat's in here, I'm not really sure what you should do. You need to stay away from that. This concludes our video on vessel maneuvering. Please check our YouTube channel for other videos.